Welcome dear audience, students and scholars. Here I'm Dr. Amjad Ali. Dear scholars, once William Bragg said the important thing in science is not so much to obtain new facts as to discover new ways of thinking about them. Dear scholars, we continue our analysis of short-run economic fluctuations, and in this video we present a model that we call the dynamic model of aggregate demand and supply. This model offers another lenses through which to view the business cycles and the effects of monetary and fiscal policy. This new model emphasizes the dynamic nature of economic fluctuations. The dictionary defines the word dynamic as relating to energy or objects in motion, characterized by continuous change or activity. This definition applies readily to economic activity. The economy is continually bombarded by various shocks. These shocks have an immediate impact on the economy's short-run equilibrium, and they also affect the subsequent path of output, inflation, and many other variables. The dynamic aggregate demand and aggregate supply model focuses attention on how output and inflation respond over time to exogenous changes in the economic environment. In addition to placing greater emphasis on dynamic, the model differs from our previous models in another significant way. It explicitly incorporates the response of monetary policy to economic condition. In our previous video, we follow the conventional simplification that the central bank sets the money supply, which in turn to be the one determinant of the equilibrium interest rate. In the real world, however, many central banks sets a target for the interest rate and allow the money supply to adjust to whatever level is necessary to achieve that target. Moreover, the target interest rate set by the central bank depends on economic conditions, including both inflation and output. The dynamic aggregate demand and supply model builds in these realistic feature of monetary policy. Although the dynamic aggregate demand and aggregate supply model is new to many readers, most of its components are not new to you. Many of the building blocks of this model will be familiar from our previous models, even though they sometimes take on slightly different forms. More important, these components are assembled in a new ways. You can think of this model as a new recipe that mixes familiar ingredients to create a surprisingly original meal. In this case, we will mix familiar economic relationships in a new way to produce deeper insights into the nature of short-run economic fluctuations. Compared to the models in our coming videos, the dynamic aggregate demand and aggregate supply model is closer to those studied by the economists at the research frontier. Moreover, economists involved in setting macroeconomic policy, including those working in central banks around the world, often use versions of this model when analyzing the impact of economic events on output and inflation. So let's discuss in this video. We are focusing on the elements of the dynamic model of aggregate demand and aggregate supply. Introduction. Before examining the components of the dynamic aggregate demand and aggregate supply model, we need to introduce one piece of notation. The subscript T on a variable presents a time. Okay, for example, Y is used to represent total output and national income. So, but no, it takes the form YT, which represent national income in time period T. Similarly, YT minus 1 represents national income in period T minus 1 or last year, and YT plus 1 represent the national income in period T plus 1, or we can say that next period. This new notation will allow us to keep track of variables as they change over time. Okay, let's now look at the 5 equations that make up the dynamic aggregate demand and aggregate supply model. First is output, the demand for goods and services, the real interest rate, the Fisher equation, inflation, the Phillips curve. For the expected inflation, adaptive expectations. Fifth, the nominal interest rate, the monetary policy rule. So let's discuss the detail of these 5 equations to make the dynamic aggregate demand and supply model. Okay, output, the demand for goods and services. The demand for goods and services is given by the equation YT is equal to Y over bar T minus alpha into TRC minus rho plus epsilon T. Here we have YT is the total output of goods and services, Y over bar T is the economy's natural level of output, and RT, here RT is the real interest rate, and epsilon T is the random demand shock, and alpha present here and alpha and rho's. Alpha and rho are the parameters greater than 0. This equation is similar in spirit to the demand for goods and services equation which we have discussed in IS equation. Okay, because this equation is so central to the dynamic aggregate demand and supply model, let's examine each of the term with some care. Okay, the key feature of this equation is the negative relationship between the real interest rate RT and the demand for goods and services YT. Okay, when the real interest rate increases, borrowing becomes more expensive and saving yields a greater reward. Okay, as a result, firms engage in fewer investment projects and consumers save more and spend less. Both of these effects reduce the demand for goods and services. In addition, we can say that the dollar might appreciate in the foreign exchange market, causing net export to fall, but for our purposes here is we are not focusing towards the open economy effect. So the parameter alpha tells us how sensitive demand is to changes in the real interest rate. The larger the value of alpha, the more the demand for goods and services responds to a given change in the real interest rate. Okay, while we further discussion to the output, the demand for goods and services, the first term on the right hand side of the equation, that is Y over bar T, implies that the demand for goods and services rises with the economy's natural level of output. In most cases, we can simplify matters by taking this variable to be constant, that is y over bar t will be assumed to be the same for every time period t. Okay, we will, however, examine how this model can incorporate long-run growth represented by exogenous increases in y over bar t, or we can say the natural level of output over time. Okay, a key piece of that analysis is apparent in this demand equation. As long-run growth makes the economy richer, the demand for goods and services grow proportionately. Okay, moving towards the further discussion related to the output demand for goods and services. Here, the last term in the demand equation, epsilon t, represents the exogenous shocks in the demand. Think of epsilon t as a random variable. We can call it sometimes the error term. A variable whose values are determined by chance. It is zero on average but fluctuates over time. Okay, for example, if investors are driven in part of animal spirits, irrational waves of optimism and pessimism, those changes in the sentiment would be captured by epsilon t. Okay, when investors become optimistic, they increase their demand for goods and services, represented here by a positive value of epsilon t. Okay, when they become pessimistic, they cut back on spending and let the epsilon is negative. So here we have previously ET, we can change it for epsilon t. The variable epsilon t also capture changes in fiscal policy that affect the demand for goods and services. An increase in government spending or a tax cut that stimulates consumer spending means a positive value of epsilon t. A cut in government spending or a tax hike means a negative value of epsilon t. Thus, this variable captures a variety of exogenous influences on the demand for goods and services. Okay, moving towards the final part here, they finally consider the parameter rho. Okay, from a mathematical perspective, rho is just a constant, but it has a useful economic interpretation. Okay, it is the real interest rate at which, in the absence of any shock, epsilon t is equal to 0. The demand for goods and services equals the natural level of output. We can call rho the natural rate of interest. Okay, then the natural rate of interest is assumed to be constant in this model. The natural rate of interest plays a key role in the setting of monetary policy. So let's move towards the second equation, that is the real interest rate, the Fisher equation. The real interest rate in this model is defined as it has been given in our previous models or videos as well. Okay, the real interest rate RT is the nominal interest rate IT minus the expected rate of future inflation expected T pi t plus 1, and that is RT is equal to IT minus ET pi t plus 1. This Fisher equation is similar in our previous video when we start the macroeconomics study. So this Fisher equation is same. So here we have Et pi t plus 1 represent the expectation formed in period t of inflation in period t plus 1. The variable RT is the account real interest rate, the real interest rate that people anticipate based on their expectation of inflation. So a word on the notation and timing convention should clarify the meaning of these variables. The variables RT and IT are interest rates that prevail at time t and therefore represent a rate of return between period t and t plus 1, that is present period and that is future next year period. Okay, the variable pi t denotes the current inflation rate, which is the percentage change in the price level between period t minus 1 last year and t present period. Similarly, pi t plus 1 is the percentage change in the price level that will occur between periods t and t plus 1. Okay, as a time period t, we have pi t plus 1 represent a future inflation rate and therefore is not yet known. Okay, note that the subscript on a variable tells us when the variable is determined. The nominal and account real interest rates between t and t plus 1 are known at time t, so that they are written as t it and rt. By contrast, the inflation rate between t and t plus 1 is known until time t plus 1, so it is written as pi t plus 1. Okay, moving towards the further discussion about the Fisher equation, the real interest rate, the Fisher equation. This subscript rule also applies when expectation operator E precedes a variable, but here you can or you have to be especially careful. Okay, the E operator in front of a variable denotes the expectation of that variable prior to its realization. Okay, the subscript on the expectations operator tells us when that expectation is formed. Okay, so ET pi t plus 1 is the expectation of what inflation rate will be in period t plus 1. We can call it a next period. The subscript on pi based on information available in period t, the subscript on E. Okay, while the inflation rate pi t plus 1 is not known until period t plus 1, the expectation of future inflation Et pi t plus 1 is known at period t. Okay, let's move towards the further discussion about the Fisher equation. As a result, even though the exposed real interest rate which is given by IT minus Et pi t plus 1 will not be known until period t plus 1. The x on real interest rate RT is equal to IT minus Et pi t plus 1 is known at time t. Moving toward the third equation, that is inflation, the Phillips curve. Okay, inflation in this economy is determined by conventional Phillips curve augmented to include roles for expected inflation and exogenous supply shocks. The equation for inflation is pi t is equal to et minus 1 pi t plus y into yt minus t y over bar t plus vt. This piece of model is similar to the Phillips curve and the short run aggregate supply equation which we have given in our previous video. According to this equation, inflation pi t depends on previously expected inflation, the deviation of output from its natural level yt minus y over bar t, and the exogenous supply shock vt. Okay, inflation depends on expected inflation because some firms set prices in advance. When these firms expect high inflation, they anticipate at their costs will be rising quickly, and that their competitors will be implementing substantial price hikes. So the expectation of high inflation thereby induce these firms to announce significant price increases for their own products. Okay, these price increases in turn cause high actual inflation in the overall economy. Conversely, when firms expect low inflation, they forecast that costs and the competitors' price will rise only modestly. Okay, in this case, they keep their own price increases down, leading to a low actual inflation in the economy. Okay, moving toward the further explanation related to inflation, the Phillips curve, the parameter phi, which is greater than 0, tells us how much inflation responds when output fluctuates around its natural level. Okay, other things equal, when the economy is booming and output rises above its natural level, firms experience increasing marginal costs, and so they raise prices. Okay, when the economy is in recession and output is below its natural level, marginal cost falls and the firms cut prices. Okay, the parameter phi reflects both how much marginal cost responds to the state of economic activity and how quickly firms adjust prices in response to changes in cost. Okay, moving toward the further discussion related to the inflation, the Phillips curve. In this model, the state of business cycles is measured by the deviation of output from its natural level, that is yt minus y over bar t. Okay, the Phillips curve sometimes emphasized the deviation of unemployment from its natural rate. Okay, this difference is not significant. However, short-term fluctuations in output and unemployment are strongly and negatively correlated. So when output is above its natural level, unemployment is below its natural rate, and vice versa. As we continue to develop this model, keep it in mind that unemployment fluctuates along with output, but in the opposite direction. Okay, moving toward the further discussion related to the inflation, the Phillips curve. Okay, the supply shock Vt is a random variable that averages to zero, but could at any given period be positive or negative. This variable captures all influences on inflation other than expectations of inflation, which is captured in the first term et minus 1 pi t, and the short run economic conditions which are compared in the second term, that is phi into yt minus y over bar t. Okay, for example, if an aggressive oil cartel pushes up world oil prices, thus increasing overall inflation, that event would be represented by a positive value of Vt. Okay, if cooperation within the oil cartel breaks down and the world oil prices plummet, causing inflation to fall, Vt would be negative. Okay, in short, Vt reflects all exogenous events that directly influence inflation. Okay, moving towards the fourth equation, that is the expected inflation adaptive expectation. Expected inflation plays a key role in both the Phillips curve equation for inflation and the Fisher equation relating nominal and real interest rates. Okay, to keep the dynamic aggregate demand and aggregate supply model simple, we assume that people form their expectations of inflation based on the inflation they have recently observed. That is, people expect prices to continue rising at the same rate they have been rising. Okay, this is sometimes called the assumption of adaptive expectation. It can be written as Et pi t plus 1 is equal to pi t. When forecasting in period t what inflation rate will prevail in period t plus 1, people simply look at inflation in period t and extrapolate it forward. Okay, the same assumption applies in every period. Thus, when inflation was observed in period t minus 1, people expected that the rate to continue. This implies that Et minus 1 pi t is equal to pi t minus 1 as well. This assumption about inflation expectation is admittedly crude. Many people are probably more sophisticated in forming their expectations. Some economists advocate an approach called rational expectation, according to which people optimally use all available information when forecasting the future. Incorporating rational expectation into the model is, however, beyond the scope of this video here. The assumption of adaptive expectation greatly simplifies the theory here without losing many of the model's insights. Okay, moving towards the our fifth equation, that is the nominal interest rate, the monetary policy rule. The last piece of the model is the equation for monetary policy. We assume that the central bank sets a target for the nominal interest rate IT based on inflation and output using this rule. We have here equation IT is equal to pi t plus rho plus theta pi into pi t minus pi t static plus theta y into yt minus y over bar T. This equation presents the monetary policy rule here. In this equation, pi t here static is the central bank target for inflation rate. For most purposes, target inflation can be assumed to be constant, but we will keep a time subscript here on this variable, so we can examine if what happens when the central bank changes its target. Two key policy variable or parameters are used here, that is theta pi and theta y, which are both assumed to be greater than 0. They indicate how much the central bank allows the interest rate to respond to fluctuates in inflation and output. The larger the value of theta pi, the more responsive the central bank is to deviate the inflation from its target. The larger the value of theta y, the more responsive the central bank is to deviate of income from its natural level. Recall that rho here, rho, the constant in this equation, is the natural rate of real interest rate. Okay, the real interest rate at which in the absence of any shock the demand for goods and services equal the natural level of output. So this equation tells us how the central bank uses monetary policy to respond to any situation it faces. That is, it tells us how the target for the nominal interest rate chosen by the central bank responds to macroeconomic condition. Okay, moving towards the further interpretation of this equation for the better understanding and better logical thought for the researcher. Okay, to interpret this equation, it is best to focus not just on the nominal interest rate IT, but also on the real interest rate RT. Recall that the real interest rate rather than the nominal interest rate influences the demand for goods and services. So although the central bank sets a target for the nominal interest rate IT, the bank's influence on the economy works through the real interest rate RT. By definition, the real interest rate is RT is equal to IT minus ET pi t plus 1. But with our expectation equation, IT minus ET pi t plus 1 is equal to pi t. We can also write the real interest rate RT is equal to IT minus pi t. Okay, according to the equation for monetary policy, if inflation is at its target pi t is equal to pi t static and output at its natural level yt is equal to y over bar t, the last two terms in the equation are 0, and so the real interest rate equals the natural rate of interest, that is rho. Okay, as inflation rises above its target, we can call it pi t is greater than pi t static. Our output rises above its natural level, yt is greater than yt over bar. The real interest rate rises, and as inflation falls below its target, pi t is less than pi t static. Our output falls below its natural level, yt is less than y over bar t, the real interest rate falls. At this point, one might naturally ask, what about the money supply? In our previous sessions, we have highlighted that the money supply was typically taken to be policy instrument of the we can call it the central bank, and the interest rate adjusted to bring the money supply and money demand into at equilibrium level. Here we turn that logic on its head. The central bank is assumed to set we can call it to target for the nominal interest rate. It then adjusts the money supply to whatever the level is necessary to we can say that ensure that the equilibrium interest rate hits the target. The main advantage of using the interest rate rather than money supply as the policy instrument in the dynamic aggregate demand and supply model is that it is more realistic. Today most central bank including the Federal Reserve set a short-run target for the nominal interest rate. Keep in mind that the hitting the target required adjustment in the money supply. For this model, we do not need to specify the equilibrium condition for the money market, but we should remember that it is lurking in the background. When a central bank decides to change an interest rate, it is also committing itself to adjust the money supply accordingly. So this is all about the elements of the dynamic model of aggregate demand and supply. So see you with another video. Ciao.